Good day, class. Welcome to our session today. In today's class, we shall be discussing about dimension analysis. Dimension analysis. When we talk about dimension analysis, we are talking about our ability to understand the component, the unit component of physical quantities. And in discussing this, we shall be looking at the three basic fundamental quantities. We shall be analyzing in terms of mass, in terms of length or distance, and we shall also be talking in terms of time. In dimension analysis, unlike in units of physical quantities, they are represented by letters. So the mass is represented by capital letter M, the length or distance is represented by capital letter L, and the time is represented by capital letter T. So we talk about the MLT. In this, when we pick a physical quantity, we try to find out at what ratio of combination is a particular quantity made up of either of these three or all of them. So let's take, for example, a physical quantity area. In mathematics, area is length times width. Length is represented with L. The width is also a distance that is measured compared to the length. So it's also represented with L. So we have L times L, which gives us L squared. L squared becomes the dimensions of area. The next one we want to look at is volume. Let's look at volume. Volume is a three-dimension quantity. It has length, it has width, it has height or thickness. So if all of them are measured as length represented by L, we have L times L times L, which gives us L cubed. It means that L cubed is the dimension of volume. Let's take another quantity, in this case, velocity. Let's look at velocity. We know that velocity is the time rate of change of displacement. That means velocity is displacement all over time. Displacement divided by the time taken. And displacement, like we said in one of our classes, is also like a distance, but that it has a particular direction, unlike the other